Hi, I'm Connor Dowling from Caregraph and a member of the Yosemite Project Steering Committee. Today's webinar by David Booth is one in a series of webinars about various aspects of the Yosemite Project. The project is a collaborative initiative whose mission is to achieve semantic interoperability of all structured healthcare information. You should see the roadmap slide now. The Yosemite Project articulates an ambitious roadmap for achieving interoperability based on RDF, and David will talk more about that in a minute, as a universal information representation. Today's webinar on standardizing the standards drills down into the left-hand portion of the Yosemite roadmap. It describes how RDF can be used as a common foundation to bridge between standards and facilitate standards convergence. Now about David, Dr. Booth is a senior software architect at Hoku Kaiu LLC, where he uses semantic web technology to make clinical healthcare data interoperable between diverse systems. He has been applying semantic web technology to healthcare and life sciences for several years at various companies for quality of care assessment, clinical outcomes measurement, personalized medicine, and research. And he holds a PhD in computer science from UCLA, right down the road from me. As a reminder, if anyone has a question during the presentation, you may email it to info@caregraph.com. I'll check my email for questions as David's talking, and I'll read them back to him in the Q&A session that'll follow his presentation. Okay, David, welcome.
Thank you, Connor. So let's back up here for just a second. So if you didn't already watch these previous webinars, then and you're starting to watch this as the recording, then I do recommend you going back and watch those first. But let's move ahead. I'm going to first talk a little bit about why we're doing this after I shut up my phone here. And then we'll get into standardizing the standards and how to do it. So the motivation for this is that there are a whole lot of standards defined in healthcare. There's over 100 of them listed in the UMLS, the Unified Medical Language System, that is maintained by the National Library of Medicine. But in spite of all of those standards, we still don't have very good interoperability. Oops, sorry, I went backwards instead of forwards. There we go. The Office of National Coordinator, ONC, has recommended a subset of those available standards that they believe to provide the best interoperability. But even that subset is a patchwork of about 30 standards, plus a bunch more clarifications to those standards, which help to achieve interoperability. So there's still quite a variety of different data formats, different data models, and vocabularies. And the standards themselves are defined in all sorts of different ways, and they are not defined in any sort of uniform computable form. Now, the President's Council of Advisors on Science and Technology in 2010, PCAST, put out a report that in part talked about this problem and identified the crucial need for a universal exchange language for healthcare information. But the question is, how can we do that without falling into the trap that is so nicely illustrated by this this XKCD cartoon here, where you start off, there are 14 competing standards, and you just say that's ridiculous. We need one universal standard that's going to work for everybody, and so 15 months later there are 15 competing standards. Well, I think the key to avoiding this trap is to take a different kind of approach, and that is the kind of approach that we're going to be talking about today. The difficulty right now is that each of the standards that we have is essentially an island. Each one has its own sort of sweet spot of use, covering the kinds of use cases that it is best at. But there's a lot of duplication and overlap between these standards and inconsistencies between them as well. So what we want to do here is use RDF is that instead of having one massive big Uber standard which would be impossible to maintain and impossible to reach in any finite amount of time. What we have is still have a number of standards, but they act as a cohesive mesh of standards that give you the appearance of a single comprehensive standard. So that's what we are setting out to achieve here. And that's what RDF enables us to do. So it's important to emphasize that RDF is not just yet another healthcare standard. In fact, it isn't healthcare specific at all. It's used in a wide variety of domains. Rather, it is a semantic foundation that can underlie all of these healthcare standards and other standards by acting as a universal information representation. So that's what we're talking about. So a common question that comes up, does this mean that we're going to have to start transmitting RDF over the wire now? No, it doesn't mean that at all. It means that we'll be using RDF to define the meaning of whatever data it is that's exchanged over the wire. In other words, defining or capturing the information content of that data. It does not have to be exchanged directly over the wire, although it could be. It would be fine to use RDF in that way as well. Okay, so now let's get into how to do this. So these are the 5 parts that are involved in standardizing the standards. The first 2 of these are essentially social efforts that need to be undertaken, and the last 3 are technical. So let me get into, first of all, number 1, encouraging free and open standards. So unfortunately, a lot of the standards in healthcare these days have licensing barriers that make it that provide barriers to use and therefore barriers to interoperability. A number of them require royalties to be paid. It can be even difficult to find them when you're looking for them, to find them on the web, for example. They're not published in a way that you can just easily look up the URL and download it and read it. You have to go through a process of paying for it, etc. So this is one of the problems. So one of the principles here is to encourage free and open standards. There definitely has been a trend, or is a trend, in that direction with standards. It is much farther along in the web world than it is in the healthcare world. But there are movements in this direction. For example, the up-and-coming FHIR standard that's being produced by HL7 is licensed under a Creative Commons license, CC0, which is just about as close to public domain as you can get, which is very good. So there are 3 Creative Commons licenses that I think are the most appropriate for this purpose: the CC0, the CC BY, and the CC BY SA. SA means share alike also. So if you're not familiar with them, I highly recommend looking at the Creative Commons site. They've done very good work on that. The next principle in standardizing the standards is to coordinate standards development. And again, this is a social process of encouraging standards development organizations to do more coordination. And what this means is to share definitions, share terms, share data models, and even share tools, so that the standards that they produce, even though those standards may be used for slightly different purposes, or maybe even very different purposes, or cover different subdomains of healthcare, that those standards can work together better. And a good example of this is there have been some good effort between the organizations that produce LOINC and SNOMED CT to enable an official LOINC SNOMED CT mapping. So that's good progress in that area. The next principle here is to use RDF to define information content. And when I say RDF, I really am referring to the entire family of RDF vocabularies. So not just the basic RDF, but RDFS, OWL, SCOS, whatever. The purpose here is to enable any sort of data format that's used for the exchange of healthcare information to have its meaning or its information content expressed in RDF. So we need to do this for both de jure and de facto standards, and also any proprietary formats that are used for exchanging data. And there are a few reasons for doing this. One is that it allows the meaning of that data to be captured independent of the data model or the vocabulary or the data format. That gives you kind of a separation between syntax and semantics. It also helps to avoid what people call the bike shed effect. And here is the bike shed effect. It's also called Parkinson's law of triviality. Parkinson observed back in 1957 that organizations spend a disproportionate amount of time on trivial issues. And the canonical example was he noticed that in an important board meeting when they had 2 items on the agenda, the approval of a nuclear power plant that was going to cost $28 million, and then approval of a bike shed that was going to cost $1,000. Sure enough, they spent 45 minutes discussing the bike shed and 2.5 minutes discussing the nuclear power plant. So RDF helps to avoid the bike shed effect by putting the emphasis where it belongs. It puts the emphasis on the computable information content and just takes things like data formats and syntax and naming right off the table, because those don't matter at all to the computer. They do matter to humans, but they do not matter to the computer that's going to be processing this stuff. Okay, now to do this, there are kind of 2 parts of doing this. One is to define mappings that go to and from RDF. So for each standard or data format that we're talking about, we need to define the mappings for mapping the instance data from that format, whatever it is, to RDF, and then the other direction also, from RDF to that format. So the direction that goes to RDF is known as lift, and the other direction is known as drop. And it's important to note that this lift operation doesn't really do any sort of semantic transformations at all. It's purely a fairly simple syntactic mapping. So the RDF that you end up with when you do this mapping looks very much like the original data that you had in whatever that source format was. So here's an illustration of this. So for example, if we were doing a lift from fire, then you would go from whatever fire syntax you had into RDF, and drop is the other way. So here's what it looks like. Here's some fire XML on the left, and here's the equivalent RDF on the right. And if you look at that, it's really the same kind of structure. On the left, it is basically a hierarchy with an observation at the top of the hierarchy, and then these 4 or 5 sub elements. And then on the right, the same kind of hierarchy. Okay, the next part of step 3 is to define the RDF data models that are used in that instance data. That's also known as the ontology for that instance data. So this need to do one of these for each of the standards or data format or whatever it is that you're dealing with. So this ontology needs to define the classes and properties that are going to be used or that are used by the RDF instance data corresponding to that standard or that data format. So it's analogous then to a relational or an XML schema, but it's in the RDF world rather than the XML or relational world. So here's an example illustration for fire. So on the left-hand side, if you're talking about the fire XML representation, then you would have some instance data on the lower left, and there's a schema that defines the structure of that instance data on the upper left. Now, once we do the lift, and we bring that into the RDF representation on the lower right, now we have the RDF instance of this fire. But then the structure of that is then defined by the fire ontology. on the upper right, and that defines the classes and the properties that are used in that instance. Okay, and there is an effort currently going on that it's a joint effort between the HL7 and W3C for defining a FHIR RDF and ontology work. So if you're interested in helping with this, it'd be, anybody's invited to help. There's a weekly teleconference about it, and we also use mailing list, etc. So please follow that link there and join in if you'd like to help. Okay, the next element of standardizing the standards, number 4, is to define RDF mappings between standards. Now that we've got the information in an RDF form and we have an ontology for them. And again, when I say RDF mappings, I'm referring to the RDF family, the general RDF family. Okay. The purpose of doing this is to enable interoperability across the standards, to have these mappings, to enable data integration, to enable query across standards, etc. And there are 2 parts to doing this, which I'll get to in a second. But I first want to forewarn you that this part is pretty hard. It's not easy at all. But as we go farther along on this interoperability roadmap, and farther along on, in particular, doing steps 2 and 5 of this track of standardizing the standards, it will get easier as the standards converge. So the first part of doing this is to define the relationships between ontologies. And what that means is mapping the concepts in one to corresponding concepts in the other. So a simple example of this would be to say that in vocabulary 1, if you've got something, the bacterial infection concept, then that might be a subclass of a concept which is broader, an infection concept in vocabulary 2. And so you could express that in RDF by a statement like this, using the RDFS subclass property. Or you might say that a concept of aspirin in one vocabulary is equivalent to the concept of acetylsalicylic acid in another vocabulary, that they're really, in essence, the same kind of thing. And a vocabulary that's quite useful for expressing mappings between ontology is known as SKOS, or Simple Knowledge Organization System. It's a W3C standard also. It is significantly simpler and less powerful than OWL, but it is in some ways easier to work with. And it has relationships in it that are defined such as broader and narrower and exact match and close match. So these are quite useful for expressing relationships between concepts in different vocabularies. However, by itself, SKOS and these kinds of relationships are not enough. There are a lot of precise mapping relationships that you will need to express between concepts that cannot be expressed in any of the standard vocabularies such as OWL or SKOS, etc. For example, suppose you have the concept of a patient address in one vocabulary, and in another vocabulary you have a concept of customer address, and they really kind of represent the same sort of thing, but they are not exactly the same. There may be differences between them, for example, differences in the way they're structured, for example, or even differences small differences of what information they include, such as one of them might have a 9-digit zip code, the other might have a 5-digit zip code. So to express the relationship between these concepts, you're going to have to define custom relationships, such as a relationship which you might call V1, V2 address to express the relationship between V1 patient address and V2 customer address. And along with those relationships, in order to define the meaning of those relationships, you'd also have to define inference rules. These are known as the entailment rules for those relationships. So let's take a look at what this means. So the second part then is to define those entailment rules for the mapping relationships. let's see. So the goal of defining these entailment rules is to allow you to do an inference given data, instance data in one vocabulary, to allow you to infer the corresponding data in the other vocabulary. That is essentially the inference that that entailment rule needs to do. So for example, given a patient address in vocabulary 1, you want to be able to infer the corresponding customer address in vocabulary 2. So what this really means is that entailment rules really kind of allow inference to be used for translation. It means that if we define these entailment rules, then we can use them to actually translate from V1 patient address to V2 customer address. And that is part of the essence of what needs to happen. So here's an illustration then. So if you have two concepts, we have V1 concept 1 in vocabulary 1 and V2 concept 2 in vocabulary 2, and we express that we want to capture a precise relationship between them. So there's going to be a relationship between them. Then there would be instance data that corresponds to concept 1 and instance data that corresponds to concept 2. And the idea of the entailment rules that define that precise relationship is that those entailment rules allow you to infer the V2 concept 2 instance data from the V1 concept 1 instance data. Okay, so here's the example then for patient address and customer address. So the relationship between them might be called, you might make up a relationship called V1, V2 address map. And then the instance data, once you have some instance data of V1 patient address, then the entailment rules that you would write and supply would allow the inference to then, in essence, take V1 patient address instance data to create V2 customer address instance data. So you can see how this kind of inference and these entailment rules are not entailment rules that are going to exist in any sort of standard vocabulary such as OWL or SCOS. These are going to have to be custom written to achieve this. And here is an actual example from a project that that I worked on last year. And this, in this example, on the left, we had a little portion of a patient record, and on the right, and sorry, it was a patient record represented that came from one system called CHCS, and so it had one sort of representation in one vocabulary, and we were converting it to a FHIR-based representation in RDF on the right. And so there was an inference that was defined, and that inference then actually did that translation of the left-hand side instance data to the right-hand side instance data. Okay, and this raises the question then of, all right, how do you describe those rules? How do you write those rules? What kind of language do you use to write them in? Well, there are a few common rules languages around, and such as in the RDF world, such as N3 or General Rules or Swirl. Another thing that you can use as a rules language is you can use the Sparkle query language, or Spin also, as rules languages in a sense. But if you think about it, really, you can use anything you want that allows you to implement the entailment rules that you need. In other words, you could use any sort of programming language you want that allows you to do the translation, if you want to call it that, where given the initial facts, produce the entailments, or in other words, the consequent facts that represent the results of that inference. So however you want to do it, you can, it will work. Okay, so that was number 4. Let's move on now to number 5, facilitating standards convergence through a standards hub. So another thing that would help a lot to facilitate this whole process of both linking different standards together, semantically linking them, and also helping to encourage convergence of standards so that different standards can kind of converge on a common set of definitions, would be to have a collaborative RDF Standards Hub. And you can think of this as a cross between maybe BioPortal or GitHub, Wikidata, Web Protege, maybe Semi-repository, maybe a few other things. And maybe it would even be a next generation BioPortal. The point is that it would act as a sort of a repository for healthcare information standards that would support both the standards groups that are defining those and maintaining those standards, and also implementers of those standards. And it would hold the RDF or OWL or whatever vocabularies you're using, RDF-based vocabularies. It would hold those definitions of the various data models and vocabularies and terms and the relationships between them. And in doing so, it can help facilitate or encourage the semantic linkage between them and eventually the convergence. So for example, some of the things that it might do, it might suggest related concepts when you're putting concepts in there, by just by using natural language processing or other techniques to try to make suggestions. It can also run a reasoner to check for consistency, both within an RDF-based standard that's being worked on, and also across standards. And it would be very helpful if this hub could be accessed not only by a browser-based interface, but also by a RESTful API, because sometimes people like to have their own favorite interfaces to things or customized interfaces to things, and that's fine. So it'd be good to have that RESTful API to support that as well. But it's also good to have a browser-based interface so that anybody that wants can just use that interface itself. Some other of the things that it should do, it should be also able to scrape or reference standards definitions that are held elsewhere. So it shouldn't require any standards organization or standards group to put their standard in themselves. And it should provide various metrics of that standard, both subjective and objective metrics, such as the size of it, the number of concepts in it, how many people have viewed it, the degree of linkage to other standards would be helpful too. And maybe even having subjective ratings. And part of the idea of it is that even though it would be based on RDF and OWL, etc., under the hood, the users of it should not have to know about RDF or OWL. That should be hidden from them. Those users should be able to be just domain experts, not RDF heads like me, but domain experts that know about their field and don't know necessarily anything about RDF or OWL. The closest that I have seen so far to this objective is a tool that was developed by Mark Muson's group at Stanford called ICAT, which is basically a customized interface for Web Protege. And this was used for defining the ICD-11 standard that has just been developed. And the success with they ended up defining some 45,000 classes and included links to 17,000 links to other terminologies. And the point of it is that because it was a customized interface, it could present the information in a way that made sense to those domain experts and hid the gory details of the RDF that it was doing underneath inside its own engine. I also want to mention that there is a somewhat parallel effort in the financial industry known as FIBO, Financial Industry Business Ontology. This is an effort to define financial standards in RDF, and it's sort of similar, but a bit narrower in scope than the Yosemite Project. And it's used primarily for financial reporting and policy enforcement. But one of the nice things about it is that they are using tools like GitHub and other automated tools to assist in the collaboration. And I think that is one of the key things that, the key points here is that by setting up a proper environment and tools and like this standards hub that I'm talking about, it could really help to encourage standards convergence that we need. So in the end, what this would end up with then is essentially an entire set of standards that are interlinked using RDF. And you might think of it as sort of a standards pool. It would include concepts from all available standards, whether they are actual official standards or just sort of proprietary formats. And it would have to capture you would have to have concepts defined in there that capture the finest granularity that is needed by any of the use cases in healthcare. That's a lot of different use cases. And it also has to continually grow as new concepts come into existence and new use cases arise. Then when you view it as a sort of a pool of all of these concepts, then you can think of an individual standard as being a sort of a slice through this pool. It's, I think, pretty important that when this is done, that you don't change the definitions of concepts. And that's important because you need to be able to accurately look back at any time to determine the meaning of some concept that was already previously defined. So what that means is that if you're not happy with one of the concepts that's in there and you want to change it, you don't change it, you define a new one and then semantically link the new one to the old one. Okay, so these are the 5 steps then of standardizing the standards. And I want to just call out a couple points on these. One is that number 4 here is the hardest of these. Defining those mappings between standards, that's hard. It's the hardest now, but as we make more progress on 2 and 5 in particular, then it'll get easier and easier as we get farther along. So in some sense, it's like trying to untie a very tight and complicated knot, that the more you just loosen a little bit, then it actually loosens other parts that you can loosen more, and eventually you can get the whole thing apart. Another part I want to point out is that number 5 is where I see the biggest payoff. In other words, the best cost-benefit ratio. That is providing a standards hub, an RDF-based standards hub, to facilitate and encourage standards convergence. So this brings us back to our overall interoperability roadmap. We've been talking about the Standardize the Standards part. In a future webinar, we'll be talking about the right-hand side, which will be on crowdsourcing translations. So this brings us to our Q&A part. And Connor, are you there?
I am.
Hi.
How are you? I'm looking at, let me look at.
So anybody that has questions can, you can email them to this email address or just to info@caregraph.com.
Yes, and I have a few already. So
okay, great.
Let me run them by you. And they're in no particular order, and they are different levels of detail. So and maybe this gets to what you just spoke about at the end in terms of crowdsourcing, but who do you expect to make RDF out of existing standards?
Yes. who should do that work of making RDF out of existing standards or expressing existing standards in RDF? So this would have to be a collaboration between people who are knowledgeable about RDF and people who are knowledgeable about those standards. And a great example of that right now is this collaboration between HL7 and the W3C. RDF came out of the W3C to do an RDF representation of fire and to define a fire ontology. So there are people involved in that effort that are both sort of RDF heads like I am, and people who are more immersed in the HL7 side of things. So that's been a really good collaboration, and that's ongoing. So I think that in general, that's the approach that will need to be done.
This is maybe a political question. Why do you think HL7 and ITSIDU and others didn't use RDF for their standards in the first place?
Why didn't these organizations use RDF for standards in the first place? Yeah, I mean, that's a matter of speculation, I suppose. But I think it's probably one of the main reasons is just that RDF doesn't yet have as much familiarity as other things. And the second thing is that this idea of using RDF in this way to achieve interoperability across standards, I don't think that's come up before. And so it's a combination of the ability for RDF to do that, the unique abilities that RDF brings to the table, and awareness. I think my guess is that those are the main factors, but that's a matter of speculation. There probably have been efforts, I know there have been efforts for people to standardize on other kinds of meta representations, but there are a number of reasons which are described in another presentation for why we believe RDF is really the best suited for this purpose. As written in the Yosemite Manifesto, it is the best available candidate for doing this. And as we're going along, we're seeing sort of more and more people recognizing that and kind of jumping on as well.
Let me just, and this is me, I'm just adding on to that question, but
yeah.
Then you gave the example of fire RDF. Would you see a time then that the other representation, and after all, the RDF representation is meant to be semantically equivalent to the proprietary one, let's call it that. Do you see a time that the proprietary one drops off, that ITSIDU or HL7 stop their own proprietary syntaxes and just use RDF?
Well, that could happen. But from the perspective of how RDF works, it isn't necessary, because all that really matters is that you're able to capture the meaning or the semantics in RDF uniformly. It doesn't necessarily mean that you have to transmit RDF on the wire. And it also doesn't mean that you have to only use RDF in defining the spec. So I think I don't think that they need to, but they may find it easiest once we get farther along to just say, hey, we might as well just use RDF from the get-go.
Here's a slightly different one. I've been using schema.org and their namespaces. How is that different?
Okay, yeah. So schema.org provides standard RDF vocabulary, a standard RDF vocabulary for describing a very wide variety of concepts that you might want to characterize in saying essentially what is the content of a particular web page or what is a particular web page about. It's really oriented toward the use of search engines. And it was motivated and initiated by the search engine giants. But there has been an effort to add much more detailed healthcare concepts into schema.org. And I think that is a very good effort. So I think it remains to be seen, though, what comes of that. I think it's really good to do that. And that is, in essence, represents another vocabulary that can be used to anchor concepts in healthcare. So
it's interesting. Again, I probably shouldn't be following on myself, but
no,
that's
go
on
ahead.
my road here. But it's interesting. I think schema.org in approach is really just saying, hey, we have one way of doing something, and everybody else take the high road. While I think what you're saying is that all of these different standards can coexist and be you can translate automatically between them, as long as you capture their meaning in one mechanism. So the singularity you're talking about is that one mechanism to capture their meaning, rather than proposing that we just coalesce on one standard.
That's right.
Have I captured it right? Yeah.
Yeah, that's right. However, there is also the goal to coalesce eventually as well. That's the notion of convergence. That is going to take time, and part of the point of using RDF is that you don't have to bet on exactly which one that's going to be, right? Because it's extremely hard to make that kind of prediction. So it does allow multiple ones to exist and to be interrelated. And then eventually, if one does kind of take over and becomes the one that people really like and really gets the usage and becomes kind of the hub ontology or hub vocabulary for everybody else, then that's fine. That's great. That makes life easier for everyone. And maybe schema.org would play a part of that. Maybe not. Maybe SNOMED CT would have enough draw to eventually become that. Or it may end up, again, still just being a collection of individual standards that work well together, that eventually are sort of become a seamless mesh to work very well together and give the appearance of one big vocabulary.
Here's one about I suppose you could say the number of people involved in all of this. Who knows RDF? How will you get enough people to do these rules?
Yeah, so RDF has been around for over 15 years, and I would say it's been sort of a slow build in its usage. It's been used for quite a wide variety of things and wide variety of domains. But there is limited expertise on RDF, so there is a learning process. So it doesn't. The farther we get along, the more we can have tools that help you to do more of this and rely less on having an expert sitting next to you. So it's a bootstrapping process. There are a limited number of people with lots of RDF expertise, but there's a lot more with some RDF expertise. And as we do tools like better tools like ICAT that I mentioned, then you don't even need to know RDF and you can do this.
Where can I go to see examples of the rules you showed in your presentation?
Let's see. I don't think we have published any. Well, there might be some in. Actually, yeah, there were some in a previous presentation that I did about a project that I worked on last year. I showed an example of using Sparkle for doing that, and I think I showed a couple of those examples. We are working on doing more right now, so we don't have a lot of examples to show right now. But that is one of the things that we are trying to bootstrap. And by the way, the examples of those rules. One of the interesting things about the Standardize the Standards versus the other parallel track in the Yosemite Project, which is crowdsourced translations, is that there's a real duality between the standardization and the translation. You noted in the presentation today that as part of expressing the meaning between different concepts, you have to define the entailment rules, and those entailment rules can do translation once you've defined their meaning by defining their entailment rules. So this crowdsourced translations idea ties in very strongly to the standardization idea as well. So once we get farther along on that and we actually do have like a translation rules hub, then we will have a good place for people to go to and look at many more. But we're not there yet.
And I'm just going to add, am I echoing?
No, I can hear you.
Okay. So you mentioned that you could use Python and JavaScript and these various languages to do the rules, so you don't have to learn a new mechanism. But
right.
Is that not the same as just writing a quick string translation in those languages? I mean, what's different about writing a rule in Python or JavaScript for RDF-based translation and just doing it straight in the language itself?
Yeah, it's very similar. And the goal is to make it as similar as possible so that the widest variety of people can write these translation rules in the language of their choice, like writing them in JavaScript, for example. And one way that we plan to do that is to use an RDF representation that is based on JSON, which is called JSON LD. JSON LD is simultaneously JSON. It is a JSON format, but it's a sort of a special JSON format that is also interpretable as RDF. So part of the hope is that by using that representation, JavaScript programmers who really don't know about RDF and don't care about RDF can actually write translations against that JSON LD just as though they're doing it against any other JSON, but it will still then fit into this same framework and same vision because it is in fact also RDF, even though it just looks like JSON.
Okay, and this is the last one I have here. It's more general. Are you proposing a new organization to standardize the standards?
We are not proposing a new organization, at least not at this point. This is, at this point, the Yosemite Project is just a collaborative initiative by people that are passionate about achieving interoperability in healthcare. It's possible that some organization might be formed down the road, but we have not thus far tried to do that. Who knows what the future will bring?
Okay, well, I think that was very informative. Thanks, David.
Okay, yeah.